In this lesson, we're going to be talking about stacks and heaps. Stacks and heaps are two different ways of storing information inside of memory, and they also have two different uses. So in terms of the memory layout, I've got a diagram here. This is how a program's memory would be laid out. So when you get allocated a chunk of memory, this is how the program would put all of the different sections that it has into place in memory. So the low memory, so let's think about low memory as being address 00000. And high memory, let's say, is FFFFF. So the low memory is where we would start what we call the text segment. Now, the text segment is where all of the program resides. So all of the actual executable code lives in the text segment. Underneath that, we would have the data segment. Now, the data segment is where any data that we know about during compile time would live. So if you've got global variables that have actual values that are associated with them, those would get put into the data segment. Underneath that, we have the heap. Now, the heap gets any memory that is dynamically allocated. So if you have a program that's using something like malloc in C, that's doing memory allocation, and it's doing that dynamically. It's doing it at runtime. That memory would get allocated off of the heap, or those variables would get stored in the heap or on the heap. Now, underneath the heap, we have the stack. And the stack is a chunk of memory that gets used in a particular way. So when the program is running, as different functions are called, we put stack frames onto the stack. So the stack is going to start at the highest point in memory and grow down, or if you're looking at it from the perspective of this diagram, it's actually going to grow up towards low memory. But it grows towards the heap, and the heap actually grows towards the stack. So we start the stack at the highest point possible, and we start adding memory to that in the case of putting stack frames onto it. And the stack is used just like you would think of any sort of stack, and the classic example is a stack of dishes. You've got a stack of dishes, you throw more dishes on top, you're always going to use the most recent dish that's on the stack. So you're going to use the topmost piece of the stack. Same thing here. When we are running a program and we call a function, we put a stack frame on there. And you can see the stack frame consists of function local variables. So any variable that's local to a particular function and is not dynamically allocated. In other words, you've declared it at compile time and you're not doing any sort of dynamic allocation of memory using a function like malloc, for example. Underneath that, we have the base pointer, which points to the bottom of the stack. And then we have the return pointer, which is an instruction pointer. And the return pointer actually points to the instruction where we need to jump back to when we have finished with this particular function. Underneath the return pointer, we have calling parameters to that particular function. And it's this stack frame where we end up getting into a certain amount of trouble when it comes to attacks like buffer overflows and sometimes attacks like format string attacks. So we're going to get into buffer overflows and format strings in some subsequent lessons, but keep this diagram in your head as we're working through some of those so that you can remember what the memory layout looks like, where the stack is located, where the heap is located, and particularly what a stack frame looks like. and how a stack frame is associated with a particular called function, and how all of the data in that particular stack frame is associated with that particular called function. So that's stacks and heaps and how memory is laid out for a running program.